Hello, this is question 16 on your November 2020 paper, paper 1 from Edexcel. You have to prove by contradiction that there are no positive integers p and q, such as this happens. And remember, when you have to prove by contradiction, the first thing you have to do is to write the contradiction. Yeah, that's how you're going to get the first mark. So if we have to prove that there are no positive integers p and q such as that happens, we are going to write that there are two positive integers. So in this case, there are two positive integers, p and q, and then we do such as 4p squared minus q squared is 25. And now from here, we have to deduce that this is not possible. Yeah, but just we use algebra or logic to deduce that that cannot be possible. So when we have an expression like this, I would say if you have squares, something squared minus something squared, I always would try to use difference of the square to factorize that. So if we factorize this expression, is 2p minus q times 2p plus q, yeah, and then just difference of the squares. And now it looks easier because we have two factors as time together are 25. P and q are integers, so that means this will be these two will be integers. So let's go into see what are the options. It could be option 1 is that the first one is, so it could be 1 and 25, 25 and 1, and 1 and 5. There are no more options, so we can explore the three of them. So 2p minus q, for example, being 1, and 2p plus q being 25. With this, for example, I'm just going to solve simultaneous equations. So 2p is 1 plus q. I can substitute the 2p, so this 2p here, and I have 1 plus q equals 25, which means that q is 24 divided by 2, 12, which could be okay. But then if I go back here to find p is going to be 1 plus q divided by 2. So 12 plus 1, 13 divided by 2. And that means that is not an integer, yeah? Not integer. So in this case, cannot be. The other option is the first one being 25 and the second one 2p plus q being 1. So let's go into see what we get. From here, we can say that 2p is 25 plus q. We substitute in the other one, so we have 2p is 25 plus q, and just substituting this thing here again. So 25 plus q is 1, which means that q is 1 minus 25 is minus 24 divided by 2 minus 12, which is not positive. And we assume that they were positive. And the third option is that both of them are 5. So 2p minus q is 5, 2p plus q 5 as well. So again, from here, 2p is 5 plus q, substitute in the other one, and I have 5 plus q equals 5, which means q is going to be 0. Yeah, and there is not positive. So these are the three options, and it doesn't work for any of them, which means your statement cannot be true. So the original one, the one that you have to prove, must be true. Yeah, so I don't know how to write without writing too much, but that means this is not possible, so our statement is not possible. It's not possible. Therefore, the original one is true. And that's all with this exam question. So this is how we prove something by contradiction. by contradiction. So just remember, the first thing, and you're going to get 1 mark for that, is to write a contradiction. Yeah, that's why it's called proof by contradiction. And then work your way out until you decide that that cannot be possible. And that's all. So our statement is not true, or not possible. Our statement is not possible. Therefore, the original is true, or something in this line. Yeah, and that's how we do proof by contradiction. Remember, it's very important that you write the first thing is the contradiction, because we are going to get a mark for that. Yeah, and that's all with this question.